Thank you. I actually wrote a much longer introduction than you're not getting. This is a 25-slide deck. There's absolutely no way I'm going to get through all of it in time. I'm just going to kind of hit the highlights, and if you have questions, please find me and ask me. I'll do a longer version of this talk at some point later on a community call or something like that. I'm going to talk about the rescue node. It's the trust minimized public beacon node that you use when you're doing maintenance to like prune and stuff like that. It acts as a fallback. I'm going to talk about why we built it and how we solved the problems that prompted us to build it in the first place. Okay, so what is the rescue node? Really quickly, Poposh sort of created it before the merge. That's a picture of Poposh in the bottom right-hand corner. And it allows node operators to just sort of continue validating even when their own node isn't really working properly. All right, so how does it work? Your normal node has an architecture that looks roughly like this. You have an execution client, you have a consensus client, and a validator client. They all talk to each other, and that's how you do your validation duties. They talk to other nodes through a peer-to-peer protocol. And then when you connect to the rescue node, it looks more like this. So your validator client is just completely isolated from your regular environment. And you can take down your execution client and you'll keep validating. All right, so the trust challenge. This is the main impetus for building the rescue node. Basically, if you just set up a public beacon node, people can steal your inclusion fees. The way that they do that is really very simple. So there's like really a very strong incentive not to use a public beacon node unless they've mitigated this attack. So we built a rescue node to mitigate this specific attack. I'm going to skip a bunch of slides right now. Oh, wait, I want to go back. Okay, so this is the original prototype for the rescue node. We just had an Nginx instance running with this bit of code in it, and literally the only thing this code does is make sure that every validator that's connected is using the smoothing pool as a fee recipient. And that way, like, nobody could possibly set your validator's fee recipient to anything else. So this only worked if you happen to be in the smoothing pool, and we only ran, I think it was Teku. So it only worked with 2 of the validator clients, I think Teku and Lighthouse. Nimbus didn't have split mode yet, so it wasn't compatible. I guess we just wanted to make a better product, so I joined Poposh. We designed what you now know is the rescue node based on this prototype. And I'll skip some more slides. All right, very high-level architecture. There's a website that you go to that makes a request to an API. The API serves you a credential. It will validate your node address against the actual nodes in our architecture. There's 5 of those. I'll talk a little bit more about those in a minute. The credentials are really cool. They're HMAC credentials, so we can actually give them to you and then not store them ourselves, and then you can give them back to us later, and we can cryptographically prove that we originally provided you with that credential, which helps us with our architecture. We'll get into that in a minute as well. So that's the API. The credentials, like I was just saying, they actually encode real data. So when you sign up for the rescue node, you'll get back a node ID, and that's like your username. You'll notice that that never changes, so you can keep using quota on the rescue node and you'll still have the same username, but the password keeps changing. And the reason the password keeps changing is that we have this message schema that we encode a bunch of useful information in. We serialize that, it's protobuf, that gets base64 encoded. There's an HMAC string in there that we can use to validate that we actually gave you this credential. And this is how we make sure that you don't use the rescue node for more than 2 weeks at a time, because we put a timestamp in there that tells us when you got the credential to begin with. Yeah, and then I guess once you get the credential, you basically just connect to a node. The way you do that is by, if you're using Smart Node, you just drop your username and password in. And we check which client you're using, and we connect you to the appropriate node of the 5 nodes that we're running. So if you're running Nimbus, you'll get connected to our Nimbus node. All right, I'm going to skip a bunch of these slides. The UI is incredible. It was made by Dan, who just gave his talk. He based the design off of a previous UI that was made by Haniabu. I just want to give him a quick shout out. I'm going to skip the API slide. I would love to talk more about this, but I think the really interesting stuff, like how we solved that trust problem, is in the rescue proxy, which is the component that I built, so I know it the best. So it's also easier for me to talk about. This validates your HMAC credential. So when your validator sends traffic to us instead of to your local node, we validate your HMAC credential to make sure that you are allowed to connect. Once you connect, we inspect 2 different requests that get sent as part of the validation workflow. Those are prepare beacon proposer and register validator. And there's like a whole lot of caching built into this application to make sure that we don't bring down any of our critical infrastructure. So the fee recipient enforcement, this is a really cool bit. This is that Nginx function that you saw earlier. For the full service, like we want you to be able to use this even if you're not part of the smoothing pool. We have to check to see if you're in the smoothing pool. If you're in the smoothing pool, obviously you have to use that as your fee recipient. If you're not, we need to know what your fee distributor address is because you need to use that instead. And for prepare beacon proposer, like this is much more important because we need to prevent other people from stealing your MEV. And prepare beacon proposer, for whatever reason, when it was designed, didn't require a signature from the validator. Register validator, on the other hand, does require a signature. So it's like way harder for someone to steal MEV from you. They can only really steal your inclusion fees. So if you're using MEV boost, a lot of the trust assumptions are reduced, which is kind of like a double-edged sword because I think, you know, some people are philosophically against MEV boost or MEV in general. And this sort of encourages you to use it. But yeah, so that's how those 2 functions work. And then at a very high level, like these are all the services that we're running on each individual node. They're in a hub and spoke architecture, which means that if individual components in our architecture go down, everything just sort of keeps working. So like we've had outages where Prism has gone down and our Prism users will be disconnected, but everyone else will be fine. If our API goes down, like the nodes keep running and people keep validating. And that's down to using the HMAC credentials, which was actually Popash's idea originally. So he's had like 2 really brilliant ideas for the rescue node, probably more than that. All right, I'm going to skip the cache talks. That's just really interesting, but I don't think we have time. Let's go on and talk about services and software. We use OVH for hosting. I have 5 bare metals and 1 VPS. It costs $508 a month. And then we use a bunch of free services. So like, obviously this is all centralized stuff, but because, you know, this is an emergency only use case, we are okay with using some centralized services like Cloudflare. That gives us certain amount of protection against DDoS. We use it for single sign-on as well for our access to the nodes. And then we use Grafana Cloud. So I upload all of my metrics into a Grafana Cloud, and then like the stats.rescuenode.com page that you can go to and see the public dashboard there. That's all through that. We're using NetData to monitor the hardware. We use HA proxy. It just gives us like a little bit of extra security and logging, and it gives us the ability to reroute traffic when we have to. And then, you know, the regular POM stack stuff, Prometheus, Grafana, and a bunch of open source code, libraries like SQLite and stuff like that. All right, and then this is an acknowledgement slide. I can't give this talk without thanking people. I'm not going to read them out individually. You can see them all up here. My name's also up here. I'm not trying to thank myself, but because of the trust assumptions involved with the rescue node, it would be weird for me to leave it off because I don't want to give people the illusion that I'm not a maintainer, because they do have to trust the maintainers to use the service. And that is it. Ken, do we have time? There is a question. I have 1 question.
Can you briefly explain how much you almost lost $250 million?
Yeah, okay, so I was asked if I can briefly explain how I almost blew up $250 million. I lost a lot of sleep that week. There was a Nethermind bug. It was a consensus bug, so it basically rejected a valid block. That caused the chain to split into 2 forks. When the chain splits and there is a supermajority client, so even though geth wasn't the one that split the chain, when the chain splits and there is a supermajority client, you can't move off the supermajority client onto the minority chain. So because the bug was in Nethermind, I didn't blow up $250 million. If the bug had been in geth, and people had switched onto the rescue node to continue attesting, and then it turned out the Nethermind and Bisu chain was the canonical chain, they would have gotten slashed if they ever tried to switch back. Yeah, so the solution there is really simple. Like, we just can't run geth on the rescue node, and if we don't run geth, this can't happen. But I think the reason that we didn't prepare for it is that until there was a consensus bug, we didn't know that people would react by hopping on the rescue node like right away. So within minutes of the Nethermind bug, there were like thousands, and I forget how many. It was like 16,000 validators or something on the rescue node. And if the bug had gone the other way, all of those validators would have gotten slashed. So yeah, my bad. And knock on wood that never happens.
Excellent. Can we get back to the